Alright, so let's look at number 38. We have to find basically everything about these rational functions. We got to find the domain, x and y intercepts, and then all the asymptotes. Then we're going to graph the thing. So, in my opinion, it's probably easier to find the x-intercept, the y-intercept, your asymptotes, graph it, and then do the domain. So, look at part A. We're going f of x equals 3 over x. Okay, so if I want to find the x-intercept, we're going to set the top equal to 0 and solve. I'm going to find the y-intercept. I'm going to plug a 0 in for x. To find my asymptotes, remember the vertical asymptote, we're going to set the bottom equal to 0. And solve. And then for the horizontal asymptote, we're going to compare the degree at the top and bottom. And there might be an oblique or slant. And that occurs when the top degree is bigger than the bottom degree by 1. Alright, so that's what we're going to do. So x-intercept, set the top equal to 0. Well, I can't really set the top equal to 0 here and have it do anything, right? There's no way that I can plug a value in and get 0 out. So basically, there's no x-intercept. Y-intercept, plug a 0 in for x. Well, if I plug a 0 in for x, I want to run into a world of hurt because you can't divide by 0. So there's no y-intercept. That's fine. You can have those. Okay. Vertical asymptote, set the bottom equal to 0. Easy enough. X equals 0. There's no solving to that. It just is what it is. So horizontal asymptote, well, your degree of the top here would be 0. Degree of the bottom would be 1. And when the bottom is bigger, it's automatically y equals 0. So if I want to graph this, see if I got a piece of grid paper here. I'm going to have a vertical asymptote at y equals 0. Get my big marker here. It's kind of hard to save. I don't use a big marker. I got a horizontal asymptote at y equals 0. There's no x-intercept. There's no y-intercept. So let's plot some points here. If I plug a 1 in, I guess you could graph this in your graphing calculator and find a table, but if I plug a 1 in, what's the output going to be, or f of x going to be? Well, if I plug a 1 in, I'm going to get 3 over 1, which is 3. So 1, 3. If I plug a 2 in, what do I get? If I plug a 2 in, I get 3 over 2, which is 3 halves. 1.5. And let's do one more. What if I have 3? 3 over 3 is 1. So 3 over 3 would be 1. So it looks like we got this kind of a curve here. Looks like it's this. And this guy will be the same. It'll be the same over here. It'll just be the points would be negative. So 1, negative 3, negative 1, negative 3, negative 2, negative 1.5. Negative 3, negative 1. So it would be coming from infinity. Follow these points. Oop, and then follow that asymptote there. So there's your graph of that. Cool. All right. Let's look. Oh, and then the domain. So domain. What x values can you use? Well, you can't use y x equals 0. You can't use that value right there. You can't. If you look at your x-intercepts, right, you got to keep those out of the domain, you got to keep your vertical asymptote out of the domain, and they're both this. You got to keep that out of the domain. Okay, so our domain here would be negative infinity to 0 union 0 to infinity. You got to keep that asymptotes, the vertical asymptote out of the domain, and if you have any x-intercepts, you got to well, you can keep those in the domain. The x-intercepts are fine. It's the vertical asymptotes that you got to keep out. Sometimes there's holes in the graph too, but I don't know if you'll find any of those. So keep the vertical asymptotes out of the domain. Okay. What about part B? Part B. Let's find our. I'll go ahead and write this out. F of x equals x squared minus 4x plus 3 over x plus 1. So we got to find our x-intercept, y-intercept, all the asymptotes. Now, I suggest that when you're working on these things and you're studying, I'm not going to go back and look at how I did this question. Okay, I want to be able to look at this and know what to do. I want to be able to look at this and rewrite this whole thing again. So I'm going to rewrite this over and over and over again. Every time I do a problem like this, I'm going to rewrite how I do them. So if I automatically it doesn't come to me how to do this question, because I'm studying here, I'm supposed to be able to look at it and do it if I'm studying for this final exam. Well, I'm going to look at this. If not, I'm going to keep on repeating the instructions over here to the side, and then eventually this will stick in my brain a little bit easier. So now I can go back and look at this paper if I want and say, well, I set the top equal to 0. Okay, but try to not look at that paper and rewrite how to do this problem out to the side. Okay, so to find the x-intercepts, I want to set the top equal to 0. To find the y-intercept, I'm going to plug 0 in. To find my vertical asymptote, I'm going to set the bottom equal to 0. To find my horizontal asymptote, right, I want to compare degrees. This might be a part 2 where you need to sit down and write out what happens in each occurrence, right? When is it y equals 0? When is it y equals a over b, the front coefficients? When is it none? And then sometimes you have an oblique asymptote. And then if so, you're going to divide it out. And you need to write down here, when do I have an oblique? And we covered that in the previous question. So first off, the x-intercepts, we're going to set the top equal to 0. So let's take x squared minus 4x plus 3 equal to 0. So I'm going to take this, factor it. Since my last number is positive, either they're both positive or they're both negatives inside here. This tells me what they both are. They're both negatives. Factors of 3 that would combine to give me -4 would have to be 1 and 3. It's the only factors of 3 there are. -1 and -3 would combine to give me a -4 there. So x equals 1, and then x equals 3. Those would be my zeros. So those are the x-intercepts. All right. Now my y-intercepts. Remember what we do here? We plug a 0 in. If I plug a 0 in here, it would kill off these two terms. I'd be left with a 3. And it'd be 0 plus 1, so that's just 1. So my y-intercept occurs, plug the 0 in for x, and it occurs at 3. Okay. So let's go ahead and grab our graph and put those in there. Where's my graph paper? There it is. So don't get confused. X equals 1 and 3. I don't know why I put that in there. All right, x equals 1. That's an x-intercept. X equals 3. It's another x-intercept. Y equals 0, 3. 1, 2, 3. That's an intercept. So there's my intercepts. What about the vertical asymptote? Set the bottom equal to 0. So my vertical asymptote. Take x plus 1, the bottom, set it equals 0. X equals -1. Cool. X equals -1 is a vertical. All right. Horizontal. The Degree of the top is 2, degree of the bottom is 1. Top's bigger. There's no horizontal asymptote. There's none. Now, there is an oblique asymptote. There's an oblique asymptote because the top's bigger. The top is bigger by 1. So your oblique would be x plus 1 into x squared minus 4x plus 3. And you'd have, let's see, turn x into x squared, you need an x. So that'd be x squared plus 1x. Subtract. That cancels. Negative 4 minus 1 would be negative 5x. Bring down the 3. Turn an x into a negative 5x, you need negative 5. Negative 5 times that would be negative 5x. Okay, I don't care about the remainder, I just care about this. Y equals x minus 5 is the oblique asymptote. So let's graph that. You start at negative 5. 1, 2, 3, 4, 5. Plot a point. You go up 1 over 1. We'll do this in pencil. Oops. I'll erase. Okay, it's an oblique asymptote, so it's a dotted line. Okay, so I'm going to have the graph come down here, follow that. It's going to come down. More likely come through here and like this. Got my points plotted, so it has to come through there and hit those. And then it's going to do something similar down here. It's going to follow that line like that. Because now I'll double check. If I take negative, that'd be negative. What happens if I put a negative 2 in? What would my value be if I plug a negative 2 in? Negative 2 squared is 4. Negative 4 times negative 2 is a positive 8. And then 3. Negative 2 plus 1 is a negative 1. So 12, 13, 14, 15 over negative 1. So negative 15. So if I go back to, I'm going to go down 15. So yeah, I'm right there on the graph again. Okay, so the graph is on this bottom part here. So what's that say about the domain? Well, you basically, it's everything but that vertical asymptote. Let's keep the vertical asymptote out of it. So let's keep that negative 1 out of the domain. So my domain here would be negative infinity to negative 1. That's what my vertical asymptote is. Keep it out of the domain. Infinity. Well, that's a good one. All right, how many more of these things we got? All right, let's graph one more. Jeez. Let's graph one more. F of x equals negative 5 over x minus 4. And the negative's supposed to go out here in the front. You can put on the negative 5 if you want. I'll just leave right there in front. Remember my x-intercept, what do? We're going to set the top equal to 0. I can't set the top equal to 0 here, so there's no way to get that the 0 on the top. Remember your y-intercept, what you do? You plug a 0 in for x. So I'm going to put that negative with the 5. Negative 5. 0 minus 4 is a negative 4. So 5/4. So I'm going to write that as a point. I plugged a 0 in for x. That means x is 0 and my y-intercept is 5/4. Alright, to find my vertical asymptote, we're going to set the bottom equal to 0. So it's x equals 4. That's my vertical asymptote. And my horizontal asymptote, degree of the bottom is 1, degree of the top is 0. So horizontal asymptote is automatically y equals 0. It's not as tough to graph this one. no x-intercepts. The y-intercept is at 0, 5/4. 5/4 would be right back here. I'm sorry, 5/4, not 4. I think 4/5. 5/4 right back here. It'd be above 1, 1.25. And your vertical asymptote is x equals 4. 1, 2, 3, 4. Y equals 0 is your horizontal asymptote. There is no x-intercept. Now, since I have a y-intercept here, I'm going to assume that the graph's over here. And I'm going to assume that the other side, he'll be on the other side. And you could graph you some points to graph it. But it's already 15 minutes to do this one problem. So use your graphing calculator or find your points same way. Domain. Remember, we want to keep out the vertical asymptote. So the vertical asymptote is at x equals 4. So the domain here would be negative infinity to 4, 4 to infinity. Boy, that was fun.